All right, let's look at the homework 4.3, problem number 8. All right, so we have the graph of the f prime given, the derivative, and then we want to answer the following question. All right, so part A, on what intervals is f increasing? All right, so increasing, so we want the first derivative to be positive. So the graph, we want the graph to be above the x-axis. So you can see that from 0 to 2, so maybe I'll start writing it from 0 to 2, right? And also set notation here, union. And 4 to 6, 4 to 6, right? And the 4, I would include 4, but I would exclude the 6 there. And the union, starting from 8 and 8 to 9, maybe. Here, 8 to 9. And we would include 8. Right? So let's check, actually, let's do the decreasing too. So decreasing would be between 2 and 4. So it's 2 and 4. And a union, union there, let's set union here. And then between 6 and 8, 6 not including 6, 8 we can include it. All right, let's check the answer. All right, I came back and that looks like I messed it up here. I didn't read this question. So assume that f prime continues to infinity. So this actually just go to positive infinity. All right, and do that. All right, let's check it again. All right, I came back and looks like we got part A correctly. All right, so what value of x does f have a local maximum? All right, so we want positive derivative to turn into negative derivative because we want to have a mountain shape, right? The hill shape. So here, like 2, positive derivative turns into negative derivative. So at 2, you would have maximum, right? At 4, it's negative to positive, so it's going to be minimum. So I'll probably put 4 there. And here, let's see, this is a positive here, and then negative here. So there's going to be a sharp corner, but you could have so positive to negative. So at 6, you could have a local maximum. And at 8, negative to positive, so it's going to be a local minimum. All right, let's check the answer. All right, I came back and looks like we got part B correctly. All right, let's move on to part C. On what intervals is f concave upward and then concave downward? All right, concave upward when it's increasing. So it's increasing from 3 to 6, and then also 6 to infinity. Right? So we have increasing. So it's going to be a concave up from 3 to 6, and then 3 to 6, and also 6 to, it's actually all the way, so it's actually 3 to all the way to infinity. So maybe I'll just do that 6 to infinity. Right, so we have that. All right, then concave downward when it's decreasing. So you can see that between 0 and 3, and that's it, right? So it's 0 to 3. All right, let's check the answer. All right, I came back. Looks like we got part C correctly. All right, and let's move on to part D. State x coordinate of the point of inflection. All right, so you can see that here, concave down turning into concave up at 3. So that's going to be the x coordinate of the inflection point. Let's check the answer. All right, I came back and looks like we got part D correctly. All right, so part E, assume that f of 0 is 0, sketch the graph of f. Right, so starting from the origin. All right, so here, uh, since the initially the derivative is positive, so it has to start out increasing. All right, first picture start out decreasing, so we can eliminate that. Second picture is okay, and third picture is okay, and the fourth picture is decreasing, start out decreasing, so that's not going to be, so you can eliminate that. So it's going to be between the second picture and the third picture. Right, so let's compare these. All right, so here, at the end here, it's decreasing here. At the end here, it's increasing here. But if you look at the picture here at the end, you have a positive first derivative. It has to be increasing. So we know that this must be the correct picture. And nothing else is reasonable. All right, so let's check the answer. All right, I came back and looks like we have the correct picture. So second picture is the correct one. And that's it. I hope that this was clear.